Ah, there we go. No big deal. We're streaming on Twitch. Let's go ahead and tell the world. Streaming game dev on Twitch. Gonna do a bunch of random stuff. Paste. There's a lot of stuff that I have to do that I really shouldn't do on camera, and I didn't get a chance to do it off camera because I was too busy playing Kerbal Space Program. So, yeah, I have to decide what sort of thing I should do here on Twitch today. One of the things we have to do is get ropes working, but I think I need to update to 2019. I'm in, where's my mouse? Mouse, there it is. I'm in 2018, as you can see here. So I didn't get a chance to update it. It was on the way home. I gave myself about a 20-minute buffer, and I used it getting rained on. So I didn't have any time to do anything before starting up the stream. I also have to get the fish working and some other stuff, but I think what might be fun is to try and get this sky working. This is obviously the surface of the water. Having a hard time with the mouse. Give me a second. Let me scrub my desk a little bit, see if I can get the surface a little cleaner. There we go. So what we've got is a plane that represents the surface of the water. And we need a shader specifically for that. So that's what we're going to build first, I think. Well, I guess it should go in... I guess I'll put it in terrain. It doesn't really matter where it goes, but we'll go ahead and create a new shader here. Amplify surface shader. The only problem with this is that it creates one with the file name of new surface shader. So we've got to change the name to, say, Topwater. And then we can open it up. Boom. Here it is. There's some values over here that we need to change. So what we're going to want to do is not have any culling, because that way we'll be able to see it from both the top and the bottom. What we may do eventually is use a different shader for the top, so that when you come up for air or whatever, you'll see a different surface. But for now, we're going to simplify it. And what we're going to want to do is have... I don't know whether we want to have a completely opaque surface or not, but I don't plan on having any stuff on the surface, aside from maybe your boat. So I think for now we'll go with an opaque shader, and we'll go ahead and just modify everything. We're going to need a couple of things, some colors. There's some colors here. So we're going to want these to be properties. We're going to call this a fade color. Then we're going to duplicate that, and we'll call this a sky color. And basically, the trick that we're going to do here is we are going to fade between these two colors based on a couple of values. What the question is whether or not we have two colors or three. Do we have a bright color, a dark color, and a distance color, or do we just have a bright color and a dark color? I think that we want to have three colors. So we'll have a sky color, and then we'll also have a what do I call it? A darker color, watercolor. We'll call it watercolor. There we are. So these three values are the values we're going to fade between. So let's go ahead and set them up. We'll make the watercolor a dark blue. We'll make the fade color a medium blue for now. We'll change it later as necessary. And we'll make the sky color a brighter sky blue. Notice that I've made the actual hue pretty faint. It's not a very vibrant color, and that's on purpose. Not at all sure that it's going to stay that way, but since they're properties, they're easy to change. So what we're going to want to do here is determine whether we can see the sky color or the watercolor based on the distance from the camera. So we have to get the camera range from whatever we're trying to render. If we take a look, we've got something called a camera depth fade. which is kind of something that might work. Let's see whether we've got any other options. Screen depth. That doesn't seem quite like what we're looking for. World space camera position. Camera to world matrix. World to camera matrix. So if we multiply our current position by the world to camera matrix, we'll get it relative to the camera. But we could also just do the world space camera position minus the current position. Compute. So I think that this is now supporting compute shaders. It didn't when I first learned it. I'm not sure. I really want to investigate the specifics of compute shaders. I'm not actually used to using them right now, but I don't think that's what we want for today. I think we just want to get the position, the world position. There it is. Boop. And so what we can do is we can just get the delta between these. Is there a delta operator? No, so it's just minus. But I want it to be a magnitude. We'll go ahead and minus and then magnitude it. No, that's min. I guess it's called subtract. Oh, I'm sure there's a distance, right? There's a vector 3 distance. Length, normalize. There's a length. Distance, there it is. Didn't that not show up? Did I search for something that sounds similar but wasn't the same word? I probably did. All right, so that's the distance between them. And then what we'll have is we'll have a property. No, that's a property. That's just a float for our ideal range. Clear range. And so what we'll do is we will compare the distance to the clear range. And if it's above the clear range, then we do one thing. And if it's below the clear range, we do the other thing. And this is a sharp edge. There's no fading. That means that when we lerp, we have to know exactly what we're doing. So what I might do is take this value, which is going to be a positive value, guaranteed. I can subtract the clear range, which we'll set up to be like 100 just for default. And that will end up being either a negative or positive value. And what we want to do is lerp if it's positive, or rather lerp between 0 and 1. The only problem is we don't have a lerp function that just takes that into account. So what we can do instead is we can take this step data. The step works in a specific way, and I always forget whether it's A or B. So we don't need to subtract after all. We can do this like this. So if B is less than A, we return 0. Otherwise, we return 1. So if A is greater than or equal to B, we return 1, meaning that this will be positive. It'll be a 1 if we end up with a distance greater than what we're looking for. So what we'll do is we'll lerp between these two colors. And we'll put in the fog later. And we'll just drag this up into the albedo. And we'll just hit save just to see how this looks before we go any further. So I seem to have lost the chat. There it is. I'll drag this off screen for now. Of course, we don't yet have an actual material, so we're going to go ahead and create a new material. There it is. So we're going to go ahead and drag that onto the water, like that. And it doesn't appear to be working. Okay, so if I take a look at the water, it actually does have the top water on it. But for some reason, it's not properly rendering. I'm not sure whether that's because it has to be in game mode, but I don't think so. Let's go ahead and just try it in game mode, see what happens. It looks like we don't have fog color anymore. I wonder if I botched something. So you can see that it already fogs due to a fog system that we built, but the camera isn't giving us the proper color here. It looks like it might be giving us black. Let's go ahead and change the watercolor so that we can really see it. It may also be that the lighting is wrong. Now that I think about it, that's probably it, because it's pointed down. So what we're going to need to do is have a different lighting approach. So right now we've got a standard light model. We're going to need to do, let's just go with unlit, and we will come back to it and do something more clever later on. Okay, so now you can see that there is a red ring. See that? But it's quite far away, much further than I thought it would be. So let's pull it in like this. And this is not precisely what we want to do. I'm coming up with a very, very quick little estimate just to see whether or not I can get it to feel right. It actually should be considerably more complex than this. But I want to get the basics in before I try and do anything complicated. And chances are that this shader already exists. Someone's probably got an equivalent shader somewhere, and I just don't know about it. But for now, we'll just do it like this. And the basic idea is that this circle is the problem. We don't want that. So what we're going to do is we're going to perturb the range. So in order to perturb the range, we are going to want a float for a magnitude. So we'll call this perturb magnitude. And then we're going to want another float for perturb frequency. All right, so what we're going to do is create some noise based on these values. Here's a noise generator for us. Hooray. So this is a simplex 2D. We can change it to whatever we want. We do not need the 3D simplex, just 2D, that's fine. And you can see that it has a size value. So I actually don't remember whether the simplex generator's size is integer based or not. But all we really need to do is drop this in. Problem is, oh, it does, good. It just connects up. I was worried that they were going to force me to create a vector too. So that's not what I want though. This is what I want. There we are. And then we multiply it over here. That was a strange flicker. And then we add. So it doesn't matter what we add to. We add to the clear range or we add to the distance, it ends up being the exact same. So we're going to go ahead and just add to the clear range because it happens to be easier to reach. There we go. And that should allow us to have a nice setup where we have a wobbly edge. Let's take a look. Save. Huh. It didn't seem to do jack. Okay, so it is doing something. You can see, however, that it doesn't seem to be... Oh, you know what? It's not asking for... My bad. I'm supposed to pass it the position. So this is going to be a multiply. And just duplicate this. And then we're going to drop in the world position times the perturb frequency. There we are. That'll do. Maybe I should make it divided by the frequency. I can't remember which direction it goes. It's fine, though. Save that. So basically the problem was I was passing it the same coordinate the entire time, and it was freaking out. So this should now be correct, but I'm passing it a vector 3. And the problem is that it's getting the wrong coordinate as z. So what we need to do is break it down and then pass it in as the x. And oh, we don't need to break it down. It's already broken down. We need to just pass it in via a composite. No, that's not it. Well, was that it? Can I do it with that? Let's just do a quick little check here. No, that's... it doesn't allow me to swizzle it, so it's not what I want. I've forgotten the name of the thing I want. As usual, just go over here into Vertex and take a look here. Well, there's a swizzle. Swizzle Z. Is that what we want? So So if we do the swizzle, we can do it. But to be honest, all I really need is the append. There it is. I don't know why I can never remember the word append. It just never comes up in my brain, no matter how many times I try and get it to work. So we were doing XY, and what we actually need is XZ. So we'll just save that. Okay, so now what we've got is fuzz. And the reason it's fuzzy is because our multiple is extremely high. We drop that magnitude down, and you can see how it cleans itself up. Now you can see that we've got really, really choppy edges. See that? So what we would do is we could change the frequency. And if we lower the frequency, we get a nice wobbly edge. Nice and easy. See? Now the truth is we don't want to use a single frequency. We actually want to use two. So what we're going to do, Pitj, Wurbus came in and said, hello, sorry if it's been a little bit, I wasn't looking at the right screen. And Pitj says, what shader editor is this? This is my favorite shader editor at the moment, which is Amplify. Amplify is probably going to have a little bit of a struggle ahead of it, since it's going to be competing with Unity's built-in shader editors in the future. But Unity's built-in shader editors are still pretty primitive, and Amplify is very full-featured. So that's why I go with Amplify. It's just got all the features I need, and I don't have to choose whether or not to go with a given rendering framework or not. Anyway, here we've got the perturb magnitude and the perturb frequency, which we're going to change to low and high. Pitch says he doesn't like the Unity built-in shader editor much. It's very young. It's not something where I would recommend that you start using it for real. Right now, it's still very early in magnitude, in development rather. So what we've got here is a setup where we're going to have frequency 0, magnitude 0, and we're also going to have frequency 0, magnitude 1. That'll allow us to create large and small waves. And as for our setup, we'll go ahead and just manually change them to some arbitrary value, but we can tweak this however we need whenever we want, so it's no big deal. And then, of course, we just add those all into the same add stack. Yep. Come on, move. There we are. And drop this into there, like so. Move this whole shebang to the left so we can see what... Wow, it's really interrupting my mouse clicks to save, which is a first. It has almost never done that. I wonder if it updated while I wasn't looking. There we are. So now we've saved it with two kinds of fuzz. Atto says shader is a good. So here's us with two kinds of fuzz. If we drop one of these frequencies or one of these magnitudes, you know, it's a weird order. Let's go ahead and reorder these arguments before we go any further here. So just bring up magnitude 0 and frequency 0. There we go. That's a better order. And we'll just get it to mark itself as dirty, and we'll save it. There we go. And it should pop right back up over here. Yeah. So that's better. If we bring the magnitudes down to 0 like this, that's what it looks like with nothing going on. So we can sort of see what happens with each of these components as we increase these values. One of the things to note is that this works in a way that is surprisingly similar to how water looks. The only reason that I created multiple frequencies is because real water is broken up by multiple frequencies of noise, right? So we're going to just increase this to something like that, just to chop it up. But in other levels, what we might end up doing is creating very different sorts of values based on how choppy we want the water to feel. It should be quite simple. But one of the things that we need to do in this particular setup is we need to make sure that these waves move, because as you can see, they ain't moving. They move a little bit as we sort of move ourselves, but if we sit, we're caught in a current, so it was moving. But if we just kind of sit still, they sit still, and that's not what we want because we're not stuck in ice. So what we're going to do is we're going to take this setup here, and we're going to add in a set of values from the timer. So we're just taking the time here, And we can get ourselves some time parameters. And the reason we're using time parameters is because that way we can just use one unit rather than doing all the stuff ourselves. So we're going to add here, and we're going to duplicate and add again. And we're just going to drop in X, and then T, and then Z. And you know what? I don't think this is going to work the way it is. I think we're going to need to allow it to have a delta. Yep, so delete this, and we'll use the time that has a delta. I mean a scale. I said delta, I meant scale. So move it. There we are. So what we're going to do is we're going to duplicate the frequency again, and this is going to be a time speed sort of thing, wave speed. We'll just drop that into scale, and then we will make two of these, wave speed X and wave speed Y. And then we'll drop those into these adds here. You notice that we're adding rather than multiplying. That's because we want it to scroll over time, not like zoom in and out. There we go. It's funny how it autosaves continuously, except for when I'm actually done. Oh well. So if we take a look now, when we hit play, you can see how there's a continuous travel pattern. It's very basic, but it works relatively well. The only problem with it is that it's not related to the magnitude of the waves. So if we wanted to have a different magnitude for this shader, we would have to be much more careful about it. We could maybe multiply them by the frequency X and frequency Y or something, the delta time. But I think that this is probably fine. We'll go ahead and use this. This is good. The only problem with this is something you may have noticed. The distance from the camera is changing, and that's because the X and Y values are not where I want them to be. Basically, I'm changing the world position. No, wait, that's fine. That's fine, because we're not changing it here. That just means I've got the... Okay, I did it correct, because this isn't part of the delta. It's just that I've got the clear range set really high. Just change that down. As we get towards the top, you can see how the waves extend further away from us. That's because of the way we're calculating distance. In truth, the opposite is what we want. We want it so that the closer we are to the surface, the shorter the range is, and vice versa. And the reason for that is because as the sun comes down, if we're near the surface, then we're going to get the light refracted through waves that are rippling on the surface. And if we're looking along the surface, those waves are going to have a lot more impact. We don't currently have that set up, though. We've got it the opposite, where the closer to the surface we are, the further away the waves are, because we're looking at the camera. So in order for that to work, we're going to need to take a distance lerp. So right now here we've got this distance. We're actually going to want to have this distance vary from a min to a max based on how close we are to the surface, rather than just being a raw distance. So when we get this distance here, we are actually going to want to lerp it. So pull this out like so. This is the distance between the camera and the surface. We're going to want to multiply it by a value depending on how close the camera is to the surface. This is a value this is something that isn't really easy to use, because how far the camera is to the surface isn't something that we actually know. What we do know, however, is the world position of the camera, Y. It just so happens that our plane is Y0. The top of the water is always going to be Y0 in this case. We could also just offset it by a certain amount. We could enter in, let's go ahead and enter that in as a property so that we don't have to do it later. So just make this, nope, there. Property, water height. And then we'll just add that in, add. Is it add? I think it's subtract. So there we go, like that. And that way what will happen is we'll know how far away from the surface we are because we know the world space here. So what that means is that we can take this value and we can lerp the distance based on it. We can decrease this. So we're going to go ahead and put in a water height factor. And right now these are properties. I'm going to change them to constants. We might want to tweak them one by one later, but until then we'll just leave them as constants. And this is going to be a camera height factor. No, that's not how you spell height. It ain't even close. Yeah, there we are. That's not even factor. Ooh, I'm not doing great with the keyboard today. There we are. So the default value, we're going to make it 0.1. And what we're going to do is we're going to go ahead and just multiply these values together. So what we're looking at here is we've got a range from the surface. We got the world space camera position minus what the water height is, which is 0, right? So if we're at negative 50, we're going to have a 50 here. That's right. So this was the wrong way. I was correct the first time. I shouldn't have changed my mind. There we are. So now we're going to have like a 50, right? So what that means is that when we multiply that by distance, it's going to make the distance go up by 50, which is the opposite of what we want. So what we probably need here is actually like a negative 0.1. And we'll go ahead and see how that works and see whether or not that ends up being a value here. No, wait, let's go ahead and make it 0.1, then we'll divide. Sorry, I'm working out this stuff as we go, and which means a lot of the times I'm not 100% sure as to what is going on. So we're going to take the distance here, we're going to divide it by that value, and then we're going to bring it down into the step. There we are. So this is the same setup, except for now the camera distance matters. So we're going to save that and take a look. So if we're down near the bottom, you can see how wide the range is. And then as we move up, you can see how short it gets. The only problem with this is that when it gets short, the frequency doesn't change. And that's not too bad. Let's go ahead and see how it looks in the game engine proper. See whether or not that feels right. We might have to adjust the amplitude. I should be calling them amplitude rather than magnitude. So if we adjust the magnitude here, we'll get a lot more range. Yeah. Well, let's go ahead and do one little trick. We're going to change the water height from 0 to 2. And the reason for that is because then when we're near the surface of the water, we won't have quite that tight a little connection. Yeah, so that's about right. Obviously, when it goes above the water, we have a problem. We'll have to figure that out separately. For now, I think this is okay. In terms of how this looks, it feels like that's the surface now. I don't feel confused by it anymore. And you can see that as we go down, we can see further and further. That's really nice. I think that that feels pretty good. And there's a lot of values that we can sort of tweak as we go along. So for example, if we were to change the wave speed x to something like 4, then we get a drift in that direction. You see? That's kind of nice. I like it. Now, the frequency and the magnitude are not axis specific, so our waves are never going to be like proper choppy bow waves. They're never gonna really have the right feel for that. But that's fine. If you're looking at the underside of the surface of the water that closely, you're probably playing the wrong game. Yeah, I'm actually fine with this. This was a lot easier than I thought it would be. That turned out a lot nicer than I expected it to. I like it. So we'll go ahead and close this down because that's good enough for now. Hooray! I'm going to go ahead and take a couple of quick little screenshots just because why not? I better not be inside of an object when I take a screenshot. That seems like a poor idea. There we are. I'll make it nice and big. The reason it's small is because I take GIFs, and I use a very tiny screen for the GIF, just because otherwise I have to shrink it. So... Sorry, someone was saying something strange on Twitter. And not as in, like, inflammatory or anything, just like they replied with something I think they didn't mean to send to me. Alright, so we're going to go ahead and tweet here. And we'll go over here. No, that's Twitch. No reason to paste Twitch screenshots into Twitch. Not terribly useful. And then we'll just go up here. Take another one. No, that's Twitch again. I'm not very good at not choosing Twitch. Made a quick little shader for displaying the underside of water. Game dev. All right, well, I expected that to take a little bit longer. I was so used to last week, which is when I did my abysmal thing where nothing worked and everything was just totally garbage. That was a real disappointing stream. But in this case, what we're going to want to do is just go ahead and try a couple of the things that we flaked out on last time. But we want this to stop blocking shadows. It's not supposed to block the shadows. So let's select it, call it water, and turn off shadow casting. There we go. That's better. Now we can actually see the ground again. All right, so what we did is we created some ropes to try and test the rope system, and it turned out that it didn't want to work. It was breaking on us instead of working properly. So what we've got here is we need to make this have a pin constraint, because otherwise it just falls through the ground, right? And if you click on Add Pin Constraint, it's supposed to pop up a thing where you click on it. Now I've rebooted Unity since then, so I figured it would work, but it didn't. So we're going to go ahead and save this scene. And then we're going to pop over to the Obi rope scenes and steal one that already has a pin. Sample scenes. So if we take a look, which ones of these are going to have pins? Probably chains. So this is one that has some nice pins going on. So this is the chain handle, which just allows you to drag this object around like so. And it has a box collider, but it doesn't have anything like a pin object on it. If we look down here at the Obi handle, that's just a particle handle, which is... Do I need to assign it a particle handle? Is that what it is? This canvas renderer just says drag me around. It's not part of the setup. So here's the chain. The Obi chain, which you can see is all bound back to the same source object. And the object pin is not there. Neither is the object tether. So what's controlling it? Is it only in play mode? I mean, it's obviously either tethered or pinned. Okay, so it's tethered. When I untether it, it doesn't change the fact that it's pinned. It just changes... Sorry, I'm trying to figure this out. And as you can see, even when it's not tethered, it runs fine. It's still properly pinned. But for some reason, I can't seem to get it to show the fact that it has a pin. It should have it has a pin attached to it, right? Maybe this OB particle handle is it's like automatically generating the pin. That seems kind of strange though, doesn't it? That shouldn't be how it works. Look, the pin got stuck in the wall. Or rather, the chain got stuck in the wall. That's fine. That's why it's tethered in the real version. Is it the particle handle? Is that what's causing this to actually work? Well, let's try another one. Here's a rope grappling hook, right? So if we go into the rope grappling hook, you can see that we can sort of just grapple to things and then use the mouse keys to, or rather the directional keys to make it work. That definitely involves some pins, so let's take a look here. What have we got? This is our chain. There's the capsule, there is the hook. The hook has no pin constraints and no tether constraints. I must be misunderstanding something. I'm not going to waste everybody's time trying to figure out what's going on here. It's clear that either I've forgotten something or something isn't showing up properly. And either way, that's not something I should waste a lot of time on camera. Seems like that would be a big waste of everybody's time. So we are going to return back over into our original scene. This doesn't seem like it's the right scene. There we are. Delete test. It's not what we want. So you can see that the top here is freaking out, and that's because our camera is sufficiently massive that all we're getting is the noise values. We could fix that, but it's not worth fixing at the moment. The actual render distance for the in-game camera will never be that far, so it's not something we normally are going to have to worry about. If we look at it from way down below, for example, you can see it just turns into a sky. We could also absolute value the range. That would also make this work a little bit better when we're above it. I guess that might be worth doing just to keep it from feeling annoying. Let's go ahead and do that. There we go. Now when we go above, it should turn into a flat blue. Yep. Perfect. The jitter is because I've got a lot of terrain at Z0. I could put it at Z1 if I really wanted to. That would keep the jitter at bay. It doesn't really matter. The player should never be able to see that. Now the other thing worth noting is that it's doing range to the camera. What it really should be doing is range to the point of impact along the camera's vector on the surface, which is something we could do. I think that there is a camera vector setup, but it's not worth it. I don't think it's gonna be any better. I mean, it could conceivably be better, but I'd prefer not to waste a million years on it. The other thing that we had to do was create some fish. Now we've got plenty of fish already, but the problem is that there's only one fish animation. And that means that when the fish decide that they're going to be panicked or swim faster or slower, that can't happen. So if we look at the fish, they should be over here. You know what? I'm going to go ahead and turn backface culling off for now, or on for now. Just so that I can actually see what the heck I'm doing. There we are. Now I can actually see. So we got fish coming along this path here, and that means that we've got to grab it. Fish, fish, where are the fish? It's right there. I'm just clicking on a rock instead. There we are. So this is our fish particle system, and you can see that we've got fish. They kind of swim. That's not a great swim animation, but before locking in the best possible swim animation, it would make a lot of sense to have it possible to do the things that I need it to do. And that means I've got to be able to switch the animation of the fish, because I've got to have the ability for the fish to not swim, and I also have to have the ability for the fish to swim fast. And preferably, I'd like to be able to lerp between them so that we get a nice setup where the fish just can move fast or slow however they need to. But there are a ton of problems with this because I'm doing it all in shader. Because it's in shader, I can't just play an animation. There's no such thing as, like, you know, a Unity animation that works inside of the shader. And I certainly can't put bones in all of these fish. So we don't really have a lot of freedom here. What we can do is we can pass the shader arguments. And we can basically say, well, this group of fish is animated using a fast animation. This group of fish is animated using a slow animation. The problem is that lerping between those it's not impossible, because I could have like a group of fish that is lerping from fast to slow. As long as they're all lerping at the same rate, that would work. But the way that I'm doing this animation involves a time. And because it takes the game's time, I multiply that game time by the speed that I want the animation to play in. Problem is, if you change that speed by a tiny amount, then it jumps forward, because if 100 seconds have passed and you were running at speed 1 and now you're running at speed 1.1, now it's 110 seconds have passed. So there's this jump. There's no real way that I know of for me to keep the state inside of the shader. What I really want is the shader to have a variable that stays the same frame to frame. I'm going to go ahead and try one more time to see whether or not I can find one. But I don't believe there is one, because what I really want to do is add, I just want to add the time delta to a value rather than trying to keep track of everything. So template parameter, what the heck is a template parameter? No. Here's a global array. Returns a value from a global array, which you can configure by entering the name of the array in the node's settings. So I think that this allows me to pass an array in, which is fine, but also not what I want, because I can't write into it. I can only read from it. And that seems to be the universal problem with all of these. They're not... You can't write into them. You can only read from them. What I could do is I could write into the material every frame. But that seems like a ridiculous idea, doesn't it? So here's the getting a local var. I can get and set local vars, but the problem is they don't keep between frames, which means that every time I try and do it, I would have to somehow write it back in using a script. I don't think there's a way to do it. Nope, doesn't seem to be. All right, so that leaves us with only two basic options. One is we never show the fish changing animation. That would not work. That's terrible. Another is that I pass in the fishy swimmy delta time, or the total time, into the shader as an argument every single tick, or rather every single frame. That's dumb, but I don't see a way around it, and if I do get a way around it eventually, it should be pretty easy for me to replace. So we'll do it that way. It's dumb, but we'll do it that way. So pass time to shader. So we'll go public string time variable name equals time. Public float delta time equals, or rather time factor equals 1. And then public material target. Is it material or is it a mesh renderer? I think it's a mesh renderer, right? The materials themselves don't have a material. Well, let's check it out. Public property block, material property block. So here in start, we're going to go ahead and create the material property block. And then we're going to set it up. And it's going to be a set float. We're going to pass it in the name of the time variable name and the value of counter, which we don't have yet. And then, of course, that's actually going to be happening in every update. And here we can set the target up properly. Target set material property block. Set property block. Set. So there's no set property block. Which makes sense because it's not a material thing. It's a mesh renderer thing. The problem is we are not using any mesh renderers. So if we take a look at the particle system here, no, that's the floating particles. We want the fish particles. Fish particles. There's no material. There's no mesh renderer here, and I don't think there is ever a mesh renderer. I think that what we get is a direct GPU call. That's how I would do it. So that means that there is no way to use a material property block for this, which I mean, we can survive. That's not like a catastrophic situation. I would like to drag you to the other screen. Thank you. Get big. Thank you. So instead of using a material property block, we can just override the material's core element. Set float. And then we just say counter plus equals time.delta time times factor. Now this is a lot slower. I'm not sure it's anywhere near fast enough. But what we can do is we can redo this setup to actually do that. So here's our fishy swim. We've got this oscillation setup that's really complicated. We don't need that. We're going to delete it and just use the raw value. But we do have to take in a time property. So we're going to just duplicate this, call it time. And its time is reserved. Fine. We'll call it something else, like custom time. There we are. And we will pass that in to oscillate horizontal. But you know what oscillate horizontal doesn't have? A time value. So we're going to duplicate this, call this custom time. And have it replace our time value. Delete this, save this. And it should, there it is, custom time. Just drop that in. There we are. Save that. It should have saved, but I still see an animation. I shouldn't see any more animation. Oh, are we taking in the world coordinates? I think what we're getting now is the fish are moving through space. So our vertex... No, this should be a local vertex position. I'm not sure why this is still animated. That's strange. So what we're going to do is create a fish. Boom. Fishy swimmy. And what we should have here is the ability to not see it move. It should never move. It shouldn't be wobbling or anything, right? It should just stay perfectly still, and it seems to be doing just that. So why were we seeing swimming stuff from the other fish? They use the same... Probably just hadn't updated yet. All right, so let's go ahead and see whether or not that now breaks the fish animations, because it sure should. No, they're happily swimming. You know what? Maybe they aren't using what I think they're using. Fish. Fishy swimmy. All I can think of is that maybe Oscillate didn't save. This is Oscillate. And this is Fishy Swimmy. Custom time is not being updated. There is no other time in here. This is not being correctly saved. That's all there is to it. There's something wrong with the way that it's recompiling, because it's not stopped. Unless custom time is doing something weird. Well, I mean, I guess what we can do is put in that new script and see whether or not it works. It just seems like a strange situation. Those fish should not be animated anymore. Oh, I think I have to put it in as like an underscore, don't I? Yeah. Let's see. So what we're gonna... Hi, Pink Hair. Welcome back. Been a while since I've seen you. We're trying to get our fish to stop animating. Alright, so we should now have fish that animate normally. Yeah, you can see how they just kind of swim along. But when we go into our fishy swimmy thingy here, the pastime to shader, and we change it to a big factor, they should swim a lot faster. They do not appear to be swimming any differently. So what we're going to do is create a fish that is not a particle, because that seems to be some sort of an issue. Here's a cube, and we'll just go to it. Where is it? There it is. Drop in the fishy swimmy. There we go. So here's our fishy swimmy cube. And now what we'll do is we'll drop in that past time value. It should actually already be there because it's a single material, right? So we're going to go ahead and not do that. We're going to just turn it off. There we are. So what we've got here is a fishy swimmy that is not fishing or swimming. It's just sitting here doing nothing. And the idea is that when we hit play, it should start to animate. So let's go ahead and hit play. A cube is probably a little bit too low poly. I I don't need it to be a fish, but basically if it's too low poly, I won't be able to tell that it's animating. There we are. So basically what we want to do is hit play and then go back over here into scene view. Stop looking at the game. Let me move the game over here so it stops being a brat. Yeah, so here you can see it's animating fine at a slow speed. If we go down into the fish particles, that's where we happen to have the thing we're looking at here. Here is our pastime to shader object, and we got a factor of 1. If we make the factor 10, it should animate 10 times as fast. Yep. So that works, except when it's the particles. I don't know why it doesn't work with the particles. If we bring it up to something even higher, like 30, yeah, you can see how they're now really, really aggressively moving. But if we look at the fish in the actual game, like here, well, it does in fact seem to be working. Okay, so I'm not sure what's going on. Those fish look like they're swimming pretty fast, I think. Let's go ahead and bring it down to 0. That should freeze the animation. They're still swimming. Why are they still swimming? If we look at the scene view, this fish is frozen because we turned the animation down to 0. So I don't know why the particles aren't following the rules. Have you tried changing shaders and changing it back? That's not a bad idea. Pink Hair is saying that it's probably just a cached shader. And now we'll go back to Fishy Swimmy. There it is. All right, so now we've changed the shader away and then back. And now we should be able to see that the fish are still swimming. So I changed it to hollow indicator, which is just a shader that doesn't do anything correctly. So we'll change it to something like the Wiggly Jelly shader. Sure, let's try the Wiggly Jelly shader. At least we should still be able to see the fish. Go in. So the Wiggly Jelly shader is built for jellyfish, and it doesn't know what the heck to do with the fish, but you can see that it's definitely having an effect. If you go back over to the Fishy Swimmy, they start swimming. Are they swimming, or is that just the particle motion? They're swimming up and down. What? No, they're definitely bending. Let's go ahead and create a new particle effect. I am not at all sure what I'm seeing here. So, new effects, particle system. Let's just drag it way up here and then make it fish. So here's our renderer. We're going to change it to a mesh, and we're going to use the fish. Fish! So there is a position component to it, but it's only internal object position, not world position. So there is our fish geo. Let's go ahead and set this up so that it's not doing anything that annoys us. So we're going to change it over into local render alignment so the fish are always pointed forward. There we are. The fish are not currently animated because default particle is not Fishy Swimmy. So we're going to go over here into fauna and drag our Fishy Swimmy nice into here. Boom. And they're swimming. So let's set the speed to 0. Maybe it does have something to do with the speed of the fish. Yeah, so they're not swimming now. But they do swim. Okay, so you are right. It is using world position. The weird thing about that is that I'm explicitly using local position. Oh, that's what it is. Yeah, you're right. Local position is the position based on the on the object's core, and these don't have an object of their own. They're a particle effect. Okay, I can see that now. So what that means is that the vertex position, if the fish are moving, they're going to animate based on their speed, regardless of what I do. Because this is like object space world position. It says so. Vertex position vector in object space. If we look at other positions, what's this? That's not what we want. Delete that. We can get the world position as well. So we could always take the world position and subtract the object position and get the No, because that'll still change, won't it? So my guess is that we're going to have to live with the fish animating like this unless we do something else. That's strange, though, because I would think that the local position would use the raw mesh position, but it must be doing some kind of... I could send the particles position as a custom vertex stream. If I'm going to start to do that, I might as well make my own setup that doesn't even use the particle emitter. Because at that point, I mean, I'm going to have to like set position and rotation anyway. And I was thinking about just having a shortcut where I set the position and the rotation of a particle system. But I could do it the same way I did debris in the debris game I made, where it is it's just a straight GPU call with no complexity to it. So if we take a look at this guy and we move him, you can see how he doesn't animate. He remains the exact same position. That's because his object position is correct. But apparently, when we use the particle emitter, it's not correct. And I think if I were to do a direct GPU call, it would be correct. I think that they're doing some kind of shortcut that is making it error out. Now, the only reason this matters is because I want to make the animations not glitch when the fish change speed. But now I have that. I have the ability to pass in whatever I want to the material. When I'm doing a direct GPU call, I think I can specify an override. But I could also just have multiple materials. As long as I'm using like a couple hundred fish, it's not a big problem. Pink Hair says, how about using texture coordinates? Ooh, there's an idea. Let's try it. Let's turn on some lights. The storm came, and the sun is no longer as bright as it was earlier. There we are. So the problem with the using UV coordinates is that we are doing the local vertex offset here. And because we're doing local vertex offset, UV and vertex coordinates might not be compatible. We'll give it a shot. So here's texture coordinates, UV. And let's just pass them in as position. We don't currently have all of the values that we would need, but we can just leave it as a 0. If we look in here, the only value that matters is Z. So that's actually the exact wrong way to do it. We're going to have to pass in a swizzled version of this. Stop. There we are. That's all we need. This is going to be a vector 3. So there we are. That should be fine. Let's go ahead and save it. See whether or not that works. So now what we should see is the UV coordinate, which ranges from 0 to 1. This will change the values, I think, because I think our fish was not a whole meter long. But it should be okay. Let's find out. Where's my new fish particles? There it is. Yeah, so that's definitely running more correct now. Let's hit play. So if we take a look, if they are being animated, it's not very fast, which is correct. We take a look down in our fish. Here is our pasta shader. We're going to go ahead and make that 50. Aha! It's working. So now we're going to bring that down to, say, 5. But we are having something strange happening. Are they breathing? It doesn't look like they're wobbling left and right. It looks like they're... What's going on? Well, you know what? We can look at the actual frozen version. We don't have to look at the ones that are moving. That's distracting. Here's our frozen fish. And you can see that it's doing something a little bit different. It's wobbling on the wrong axis. That's interesting. It shouldn't be able to do that. So, it's supposed to wobble. You used V instead of U. Oh, yeah, you're right. I'm just an idiot. One more time. That's better. All right. So let's go ahead and bring that fish system into play again. I think that 1 is too slow. I could modify the shader so that 1 is correct, or I could just change our base speed from 1 to like 3. Now the only thing that this does is it gives me the ability to set the speed of the animation via a script. One of the problems with this is that all of the fish that are drawn with the same material are going to be drawn in the same phase of their animation, since there's no world coordinate to work from. There are ways around that, but for now I don't think I care that much. We'll work on it later if I decide it needs to be worked on. But the ability for us to assign different values to these materials means that what we'll probably do is create a couple instances of the fishy swimmy material, and we'll use them to ramp between different groups of animations. But it won't be like this cluster of 10 fish are all slowly accelerating and this sector of 10 fish are all slowly decelerating. It's going to be this cluster of fish is actually rendered with 4 different materials. And some of them are accelerating, some of them are decelerating, and so on. Now, the reason that it has to be like that is because I need to be able to pass in the time argument to get the animations working, the custom time argument. I don't know of a better way to do that in Unity's setup, because I don't know of any way to store a value local to the shader's object. So basically the issue here is I want to have a delta time that I add to a local value rather than using game time, because if I change the speed of the animation, I don't want the game time to suddenly be 50 times larger. I just want the animation to work 50 times faster for a brief amount of time. That'll keep it from jumping. But the problem is that there's no way to store a value, as far as I can tell, inside of the shader or the object. So what I would do, I could do it. I could use a custom array. There it is. By using a global array, I could in fact pass the shader, not necessarily even the position, but just like an arbitrary value for each of the objects in question. That would let me, instead of passing the entire... Yeah, this works much better. This works much, much better. Okay, so what we're going to do is our base speed. Now, hold on, because how do I tell each fish object which index they are? Pink Hair says custom vertex streams from the particle system are per particle. That would be nice. I don't know how that works. works. Do you have an example of how that might work, Pinkhair? Because I'm not sure how to actually set that up. I'm trying to think about the best way to do it, because I don't have any access to which number this is in the list. So that won't work. But if I could pass in customized per particle values, then all of this would be fixed, because I wouldn't need to have multiple shaders or anything. I could just use the per particle custom submission to do all of that complicated stuff, and I wouldn't have to worry about having like 8 different materials doing different things at different times. I could just animate each fish. So that would be great. Anyway, for now we're going to call that pretty solid. I'm going to just fart around for a little while longer. If you do know anything about this sort of setup, especially how to pass information from a particle system into a shader, and I'm using Amplify in this case. If you know how to do that, let me know now or later, anytime, because I'll need to know it basically forever. But there are some other things that are worth considering. I can't get the Obi rope quite working. So Pinkhair says the particle scroll down to custom vertex streams. In the particle system, scroll down to custom vertex streams. Then you can encode things. Okay, let's take a look. Since I got someone who knows how to do it on the hook, there's no reason for me to sign off. Custom vertex streams. Presumably that's right here. Vector and color. Aha! Number of components, 4. Okay, so when I set these particles up manually, am I able to set their custom data manually as well? I'm sure I can, right? Because I can set their position and their velocity. I should be able to set their custom data just as easily, right? That's the idea anyway. Let's go ahead and try it. So now I'm passing in custom 1. And apparently it's forced to be called custom 1. So if we open the shader editor, I now have a value called custom 1. How do I get that into my shader? Do I create a property called custom 1? If I do this, is it just going to work? Well, I suppose I can find out. What we'll do is we will temporarily replace the amplitude with custom 1. And we'll just see whether or not that ends up being varied. So now I have custom 1 passing in a value between 0 and 10. Pinkhair says he's not used to using this. Okay, that's fine. We'll see. We will see. No, it didn't work. All right, so let's take a look on the internet. Amplify, shader, particle, custom 1. Oh wow, amplify.pt is the slowest web page. There we are. I'm trying to figure out how to intelligently access the particle's custom vertex streams. If I enable custom 1 as a vector and then expand my renderer and set custom vertex streams to true, I can now see everything is packed and set in. I can see Unity is trying not to be wasteful by packing things into the empty text coord 0 inputs. How do I access stuff in vertex stream? For vertex streams, you are only allowed to use from text coord 0 to text coord 3, and each text coord has 4 channels available. In the custom vertex streams, your text coord XYZ0 would be UV set 2, which, okay, so let's go ahead and try that. So the idea here is that according to this, it would be UV set To access this data, you may use the vertex text coord node. Texture coordinates. Now we're already using some texture coordinates, but these aren't the same ones. So what we're going to do is delete this. And over here, we're going to use U. Now the idea is that what we really want is for this to be set to texture coordinate set 2. We recommend you use the vertex text coord. Okay, let's see if we can find that. There it is. Vertex text coord, UV channel 2. Why is this? This is not what they're showing in their drop down. Well, we'll give it a shot. Da, 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 da. All right, well, we might have to try a couple of different options here because I don't actually know whether or not that's going to work. But I don't think I have to press play for it. What I can do is just look at my fish. My cube fish. Yeah, look at that. That is correct. Right? Might not be. Oh, I have to look at the particle effect. So hold on. Let's go down to the fish particles. Basically, we want each of the fish. Where are the fish? We want each of the fish to have a different magnitude. And what we see here is that all the fish have the same hook. That implies that this is not actually using the correct vector coordinate. So we're going to switch it over to 3, which I can do off screen in case you're wondering why you can't see it. That's not it. But it shouldn't be a, I mean, why would the U be a 0 or a non-zero? If it's 0, then we shouldn't see any amplitude at all, right? So if we set the amplitude to 0, hello, save. There we are. So if you set the amplitude to 0, you get this. So the vertex text coord isn't 0. But it's also not what I'm trying to get. There's something wrong here. It's not varying. Well, I've tried all of the lower level coordinates, and none of them are really doing it for me. I think it's using the same vector. I think it's using the same setup for all of them, regardless of which channel I'm trying to use. Just check and make sure nobody said anything here. You have to do it in the renderer. That is the renderer under particle system. Okay, I see. Let's go ahead and try that. So here's the renderer. Ah. Vertex streams do not match the particle streams. Particle systems may not render correctly. All right, well, that's fine. So I don't care if they don't match, but these aren't the ones I want. Custom. Custom 1XYZ. Text coord 0 ZWXY. If you say so. But that means that text coord 0 is playing double duty? Why is text coord 0 playing double duty? how do I change this so that it's not playing double duty? Well, here at least text coord 0 is no longer overwriting. But it doesn't seem right. That seems wrong. Let's give it a shot. We got text coord 0 now. So here's text coord. Here's 0. That's not 0. That's 1. ZW. XY is now ZW. Does that mean this? That doesn't seem right either. Well, at least it's 0. Let's hit play and see if they're all 0 all the time or what. They all are 0 all the time, so that's not the correct value. I should be able to tell right away because some of the fish should have a much larger scoop than others. Ah! Well, that seems to be it. Good. So it's W. It's texture 0W. Obviously. Except for it's not. It's texture 1, 0. Whatever. It works. That's good enough for me. So obviously that's not what we want because amplitude is supposed to be amplitude. But now that we know that W is here, what we can do is we can use this to change the base speed. So we can multiply the base speed times W. But that's not quite right because of the way we change things otherwise. We're going to go ahead and keep tweaking this until it works the way we want, but maybe some of that will be off screen. Being able to pass these in turns out to be very, very useful. Thank you so much for stopping in, Pink Hair. You pulled me fat out of the fire. If you want to see what I did without you, look at last week's or last times where I completely flubbed and nothing worked and I was just hopeless. It was so awful. So we have the amplitude set to 0 for stupid reasons. Just go ahead and pump that amplitude up and press play again. So you can see that now we have a lot of different speeds of fish. The only problem with this is that as I change the actual animation speed, they're going to flicker. Obviously right now they're flickering because some of the speeds are ridiculously high because I wanted to test it. So we'll go ahead and make this 0.1 to 3, maybe 0.5 to 3. But the problem is that as those values change, we're going to end up multiplying the total time by the new value rather than the old value, and it's going to end up creating a really big jump. And that's what we were trying to avoid in the first place. So now we're right back where we started. But the good news is I can still use the delta. It'll just mean that certain fish are going to swim faster than other fish all the time. But the other thing I can use for these is I can use it to offset the fish animation, which instead of multiplying it, I would simply add it. So let's go ahead and do that. So here is where we're multiplying, and what we actually want to do is add. And that'll just keep all of our fish from having the exact same cycle. Yeah, Pink Hair is commenting on the same thing I was commenting on. So now you can see that the fish are no longer all swimming in the same exact cycle, so it's a little bit less robotic. Of course, they all are currently using the same speed, but here's the thing. I can pass the delta time for these fish into their custom time stream instead of into the shader's time stream. I should be able to do that with the y coordinate, which should be z. So that would be writing into this value here. Let's go ahead and see whether or not I can actually do that. So we're going to need a new script. We're going to go ahead and call this pass time to particles. And it's going to be basically the same script. So we're just going to grab this crap and paste it in, and then just change the things that need to be changed, like there's no time variable. So the material target is not what we're looking for. We're looking for a particle system. I actually don't, I think it's just called a particle system. Let's try it. So what we really want to do is set our particle system dot particles. We want to just go through all of the particles, but I don't know how to do that. Let's make sure that we've got the right thing first. So go over here, go back out into our particle system setup. Here it is. Here is our fish. Grind, grind, grind. Here's our pass time to shader, and what we need is also a pass time to particles, which will replace pass time to shader if I can get it to work. So here is the particle system. Let's see whether or not that actually accepts the particle system as an argument, or whether I've got the wrong class. There it is. So I can pass the particle system in. Now the question is, how do you get the particles? I'm going to go ahead and name this particle system. Now there's already an existing particle system, so we're going to go ahead and punch in a new there. Because what we want is for us to also have a particles argument. So we'll have to figure out how to get the particles. Main module dot I don't see it. I don't see any sign that it's in the main module. Unless... Nope, I don't see it. So it's probably not in the main module. Particle count. Close. Particle system, which should be the same thing, right? Particle system dot particle system, it should just be an endless loop, right? Yeah. Here's the renderer. So we could pass custom things to particle system. We could use this renderer to pass in a material property block, unless this is not the renderer I think it is. No, this is clearly a renderer, but it's not a specific renderer. Like it doesn't have the arguments I'd need to cast it to a specific renderer. Is it a sub-emitter? Do I have to get it from one of the sub-emitters? No. Here's emitting. Ooh. Pink Hair says I should pass the particle time. The particle age is unfortunately going to scale by the same amount. So if the particle is 3 seconds old and then I change the animation speed from 1 to 1.1, the particle will now be 3.3 seconds old. And that means that there is a 0.3 second animation that gets skipped. So I don't think that would actually change anything unless I could set the particle age as a value, which is maybe possible, but I have to access the particles first. Here's get custom particle data. Is there a set custom particle system data? Yes, there is. Okay, so it looks like this is how we do it. Get and set particle system data. List vector 4. particle system data equals new list vector 4. Yeah, and then what we'll do is we'll get particle system data. Custom particles, there it is. We'll pass in PSD. I think it writes to it, unless I'm mistaken. And we're going to want to get particle system custom data stream index, I think 0. Let's go ahead and see whether this works by making it something we can actually public blah. Ah. There we are. So what we're going to try and do here is see whether or not this actually generates anything. So to do that, we're going to play in paused mode. So here's our PSD. It's currently at 0, and it's still at 0. It says null reference, object not... Oh, we forgot to actually set the particle system. Brilliant. There we are. And you can see that now what we've got is all of these custom data with the X value being the randomized value we're setting, even though in the shader, it's the W value. But that's fine. I can live with that. So what we're going to do is we're going to pass it in as the Y value. So in order to do that, we just go through this list. So we don't even need to get it. We need to get it once. No, wait, we do need to get it constantly. All right, that's fine. For each, I guess we'll just do the for. For int len equals psd.count. For int a equals 0, a is less than len, a plus plus. psd a dot y plus equals time dot delta time times factor. Now, the thing about that is that there's no randomness to it. Oh, we can't do it like that. Curse you. Vector 4. There we are. And then at the end, we set it back in, particle system.set custom data, PSD 0. So that should work. I'm a little bit concerned about the vert streams, or rather the stream index. I'm not at all sure that the stream index is always going to be 0. We'll go ahead and jump that beach when we get to it, though. So here you can see that what we're going to do is we're going to add to the delta time. This is just to get us started and see whether or not it works. So in order for that to work, we're going to need to plug it in properly in the shader editor. So currently we're using W, and I think we have to use T now as our custom time. No? What's going on? That was weird. It was trying to save something that wasn't expected. All right. So obviously nothing is happening right now. We're going to go ahead and turn off pass time to shader because that shouldn't be a value anymore. And we're going to go ahead and see what's happening with this pass time to particles. Now it should be running really slow due to displaying a whole bunch of things in the inspector over there. But what I don't see... So time is advancing. If we look off to the side, you can see how elements do gain time over time. But it looks like they're just playing too slowly for us to see. So let's do two things. First off, let's go ahead and hide that, because that's it's just something that's being displayed, and that's not going to work for us. And now, you shouldn't have to write hide in inspector on a protected value, but I have had problems in the past where large lists would be calculated as if they were going to be displayed, even if they weren't going to be displayed, which would slow everything down. So hopefully that'll work. And then we'll just change this to 10. But I'm not at all sure that we're actually reading the value correctly. It might not be W. For now, let's go ahead and make it X, because I know what X is. It's not working. Now I know the values are actually increasing, but for some reason the custom particle data is not being passed to the renderer properly when I set it. I don't see any error messages. So there must be something wrong with the pipeline. I mean, it doesn't get any clearer than this, right? Get it, set it. Now, because particles are constantly being created and destroyed, particle 0 is not going to be the same particle at all times, so we will see some jumping. But it should go up. Yeah, look, I mean, it's going up fine. It does appear... I don't know whether we're seeing excessive jumping or whether it's getting reset, because it's just oscillating between 2.4 and 2.6 continuously, which kind of implies that it's not permanently changing those values. What if we were to tell it to not generate them? If we go up here and we actually turn off custom data like this, but we leave it turned on down here, is that going to make it work? Yes. Now it works. But the fish are not animating because the custom data we're passing in is not the time data, it's the position data. So we're going to make this Y again and see whether it starts to animate now. So if I generate the custom data, it actually overrides my attempts to override it. It has priority. That's no good. So we have to let it just... There we are. You can see how they're swimming. And that's good. It's obviously stupid fast, but as far as basic data goes, that's not bad. The only problem with that is that we're no longer passing in an offset, so we're going to have to deal with that. But for now, let's remove this and set this down at, say, 2, and see how that looks. Now we can keep track of the particles individually and give them all their own animation speeds, if we want to. We won't bother at the moment, but you can see how they're all robotically swimming at the same pace. What we're going to do is, if the value isn't 0, or if the value is 0, we're going to change the X value. That ought to allow us to just set their offset when they're created and then not worry about it afterwards. That should give everybody a different phase without having to worry about whether or not they are currently set or trying to keep track of which particle is which. Now in the long run, we're going to have to control when the particles are created and destroyed. When we do that, that's when we will start to, you know what, I think that it's not quite enough. Once we control when the particles are created and destroyed, we will be able to track which particles are which, and at that point we'll be able to give them a state that lasts longer than they currently do. But since the particles are currently created and destroyed by the particle system, we don't know which particle is which. They're randomly destroyed and created, and the index changes all the time, so we can't really keep track of them like that, but we can keep track of them like this. All right, well, we made some great progress today, thanks mostly to Pinkhair, and that is good enough for me. Thanks for hanging around, everybody. I'll pay attention to chat for another 5 minutes or so, but I am happy with how today went. And thank you very much for your time. I'll see you again on Saturday. Maybe we can get the rope working by then. I'll try and upgrade Unity at some point before then. Have a nice one.